Hey everyone, welcome back to the channel. Whether you are a developer looking to build the next big AI voice app or a creator needing custom voiceovers for your videos, audiobooks or games, today's tutorial is for you. I'm going to show you exactly how to clone any voice entirely for free using the Qwen TTS model. We'll be working with a bit of Python, but don't worry if you aren't a programmer, I will guide you step by step. We'll be running everything in Kaggle, which gives us free GPU access, so you won't need an expensive PC to follow along. Let's jump right into it. So go to Kaggle and create a new notebook. Go to the Settings tab, Accelerator, and select the GPU T4 option. Kaggle provides 30 hours of GPU per week, which should be more than sufficient. Then we have to install the Qwen TTS dependency. It will take some time to download and install, so I will just skip this part. Alright, now we have the dependencies installed, so let's import the required libraries and then initialize the model. So here I have used the 1.7 billion base model, and I have commented out the flash attention part because flash attention only works on NVIDIA Ampere supported GPUs that include RTX 30 series, RTX A series and data center A series or newer models. But here we are using a T4 GPU, not an Ampere GPU. So the next step is to initialize a voice clone prompt, for which we need a reference audio and a reference text for the reference audio. I will upload a voice sample of Severus Snape from Harry Potter. I will just drag the file into the upload area, give it a name, let's say voice sample, and then click on create. Alright, the sample audio has been uploaded. Now let's close this, and you can see under the dataset tab that our voice sample dataset has been created. Now I will pass the path of this file into the reference audio and then just paste the transcript text in the reference text variable. Now we have to create a voice clone prompt that we will pass for text-to-speech voice cloning. To create the prompt, you have to call the create voice clone prompt method and then pass the reference audio and text that we just created. Okay, so before cloning the voice, I will save this prompt for future use. I will use numpy.save and pass the prompt in here. Since the prompt output is a list, therefore I have used indexing to get the first element only. Then I will load the saved prompt. Use numpy.load and then paste the file path. And don't forget to set allow pickle as true. Since this returns a numpy array, I have used .item method to get the inner object. So let's start cloning. So here we are calling the generate voice clone method. Inside it I have provided the voice clone prompt and the famous dialogue from Spider-Man as text input. Now let's just run the code and check the output. To save the output, we have to use sf.write method and pass the output file name with .wave extension, the output tensor and the sampling rate. Okay, so the output audio file has been created. Let's play it and hear how the dialogue sounds in Professor Snape's voice.
Mr. Potter, pay attention. These are the years in which a man decides exactly what sort of wizard he intends to become for the remainder of his life. I suggest you be exceptionally careful about who you choose to be. This boy, Malfoy, perhaps his fate was earned, perhaps it was even deserved. But simply because you possess the raw, unthinking power to crush him. It does not grant you the right to do so. Control your impulses, Potter. Try to grasp the simple fact that with great power comes great responsibility.
So, this is how you can create a clone of any voice for free and use it for text-to-speech conversions. Before we end, I have a few tips for you. Number 1. Do not provide a very long text as input as it may run out of memory. Number 2. Instead of providing the entire text at once, it's better to break it down into smaller paragraphs and provide the list of paragraphs as input. I have done some testing behind the scenes and you can see that normally it took nearly 87 seconds to run, but when I broke down the text into a list of sentences, it took only 50 seconds. Now this was a very short text, but you would notice a significant difference while processing longer texts. So this is how you can provide a list of texts as input and then merge the outputs into a single tensor and then export it as a single audio file. The third tip is that you can use some arguments to fine-tune the LLM output, such as temperature, top K, top P, and max tokens. A low temperature makes the voice generic and safe, while a high temperature allows the model to be more dynamic. Top P ensures that the model stays within a pool of logical sounds, so it doesn't turn into pure static or white noise. And top K controls the diversity, keeping this around 50 prevents the voice from becoming glitchy, while still feeling designed. You can use max tokens to limit the number of output tokens. It could be useful if you're building a service app where you want to limit the usage per user. Last but not least, you can also design your own custom voice. For that, you have to use the voice design model instead of the base model, called the generate voice design method, and in the instruct parameter, pass a description of the voice that you would like to create. The input and output format is the same. You can save the newly created voice and then use it for text to speech. And that's a wrap. If you found this tutorial helpful, please drop a like and hit that subscribe button so you don't miss out on more AI coding guides. I've left a link to this Kaggle notebook in the description below, so feel free to copy it and experiment with your own voices. Thanks for watching and I'll see you in the next one.